respect to yesterday's presentations, and if you had any comments on any of the speakers, or any specific topic that you want to bring it to our attention, to the attention of CBIP and IGEF, because we have been conducting quite regularly these programs, and your feedback will help us in improving the future programs, especially in selecting speakers and also selection of topics, and if there is any lacuna on the part of the technology. Whatever feedback you have, I saw some comments on the WhatsApp chat that people wanted the queries to be posted on the chat. I mean, we could do that. I mean, in the past training program, in fact, I used to read out the chat queries. The only reason why I encourage people to unmute themselves and speak is, I mean, it's faster, I thought, but somebody had commented, I think it's slower, or it's rather little time consuming than the question being posed directly to the speaker. Yeah, there are always pros and cons with respect to both the queries being posted on chat or being asked directly by the respondents themselves. I mean, whichever way is comfortable with you. Coming back to one specific suggestion that was made by S.K. Mishra, Director SECI, yesterday, I don't know how many of you had the opportunity of listening to a visionary or a thinker called Tony Sheba today morning at 9 o'clock under the Invest platform. It was quite mesmerizing, to put it, the presentation, the half-an-hour presentation. I will just tell you a few points that he made before we get on to the feedback. He says that India can achieve 100% renewables or clean fuels with the solar, wind, and battery. And this is based on some dynamic simulation modeling exercise. The figures that he has arrived, I mean, there are three scenarios. One is with the lowest capex, I would like to recall. He says with the capital cost of about $365 billion investment, with a solar capacity of 810 gigawatt, a wind capacity of 70 gigawatt, generation capacity would be in 4.8 times, and a battery capacity of 2263 gigawatt hour. He says the battery average demand would be as low as 21 hours, and the annual super power generation would be something in the range of 365 terawatt hours. And he goes on to give the electricity cost and all that. He has arrived at these numbers based on 2 years demand data from January 2018, I believe, to November of 2020. And he calls it as India becoming a superpower in the literal sense of the power, electricity power. In case some of you have missed listening to that wonderful presentation, you could also, I think, go to the Invest website and search for that presentation. The reason why I'm saying is because we all come from this very interesting subject called solar sector, and the way the planners, the thinkers are looking at how the whole solar business would develop in the next few years. Okay, coming back to the feedback, I mean, if somebody want to either put it in the chat or unmute yourself and say something about yesterday's presentations, the three presentations, or rather the four presentations that we had. Yes, I can see Mr. Chandrasekhar from GE Gas Power. Yes, Mr. Chandrasekhar. Yeah.
Good morning, everybody. This is Chandrasekhar again from GE Power from Switzerland. So thank you very much, Mr. Anil Kumar, for organizing this training program. So I think this is very much impressive, and the way how it is organized. So I think I will just not go in detail, but I will just say thanks to everybody for yesterday's presentation. Mr. S.K. Mishra and Hans Henning, S.S. Mishra and Andreas Franco and Mr. Jamgaonkar. So basically what I found out, the way how we organize the training program. So once we started with Mr. S.K. Mishra, and then Hans and S.S. Mishra and Andreas Franco. So we have a basic overview and idea, how about the floating solar. So I think that we have come to an understanding that there is a good potential on it, but we understood that there is also, not an alternative for the ground mounted because of the cost in the current day. Maybe it may change, in the perspective with the design changes, and also maybe the cost, because of the cost impact, and if you manufacture make in India and all this kind of stuff. So I think from my side, being in the first entrant, saying as a as a basic aspirant in this floating solar, so it was very interesting, and I appreciate the way it has been dealt. And also further, after going into the presentation of Mr. Andreas Franco, I think it has opened up a more light and clarified many doubts about in detail, because the way how he's presented is very much real experience, and the shade is very much practical aspects, which needs to be taken into detail. So I would like only one thing, just maybe if it is possible, maybe in future or in present. So if we can get kind of one case study of one project, and just go in detail, just to be sure that we understand all the, because right now we are just going into like an superficial way. But if you can just take as in one case study of one project, from the very beginning, from the like a feasibility study, and also from the ending execution of the project, and the how the project has been O&M, operation and maintenance. So if you can this will give a real good experience. I think today we will have a virtual tool, but that will be like giving an IF and view. But if you can have a case study in one of these training programs, maybe it will also encourage the people to ask more questions, and also give more practicality, and also look into it to help them to look forward on this aspect. Yeah. Thank you very much once again. Thanks a lot.
Yeah. Thank you, Mr. Chandrasekhar, for your feedback. I mean, we really appreciate that. Coming back to a suggestion on the case study, I think, yes, I mean, you are absolutely correct. I mean, I think it will answer, I mean, your query will be answered by today's presentation by Mr. Ayub. It's not just the virtual study tour. It will also talk about right from the planning to the implementation of the project, because it has been successfully implemented for the last 3 years without much of a problem. Incidentally, we had this, as I explained yesterday, we had this best practice study tour to Wayanad 2 years ago, where we had almost similar number of people participating. I mean, we had about 85 people, close to that. And then we all visited that, and then we had this seminar. I believe that it will be in the form of a case study, how they went about implementation, although it's a small, half a megawatt project. But there are lots of learnings which I hope Mr. Ayub will be able to share. I do take that suggestion, and we definitely would keep that in mind. Thank you, Mr. Chandrasekhar, for your comments. Yeah. If there is one more comment, we would accept that. Yeah. Would somebody also like to talk? If there is nobody, then okay, that's fine. Yeah, maybe at the end of this day, we also have a feedback session. Maybe at that time also you could talk about it. Okay, fine. We are already close to 2:40 now. We have lined up 3 presentations today. The first presentation is on the floating solar photovoltaic, a third pillar to solar PV sector, by Mr. Mohit Acharya from TERI. As most of you must be aware, TERI is one of those well-known and reputed institutions who have been working on a range of topics on renewables and sustainable development. Followed by a presentation on risks, bankability, and environmental considerations by my dear friend Mr. Vivek Jha, who has enormous experience in the floating solar. You could ask any kind of question on the topic, he will be able to answer. He was also a faculty when we did this study tour to Wayanad plant last time. Then last but not the least is the presentation by Mr. Ayub, who is the executive engineer at the Kerala State Electricity Board, the owners of this beautiful Banasura Sagar dam. Why I say beautiful is the whole area of Wayanad. I mean, if some of you must have visited Kerala, it's really mesmerizing and breathtaking kind of a scene over there, and especially the way they are maintaining that plant and that visit itself is it's very nice. So we have lined up this presentation. Just again to repeat the housekeeping measures, kindly mute your audio when the presentations are on. And as I've said, I mean, if somebody wants to raise a query, you could put it in the chat or you could unmute at the end of the presentation. And then somebody had asked about the PPTs. Yes, I mean, they will all be available on the Central Board of Irrigation and Power website and also on the website energyforum.in, where I come from, the IGEF. We will share the details. Also, this is being recorded, and the YouTube will also be, I mean, the whole recording will be made available on the YouTube. And then we have the e-certificates, which will all be sent. And yeah, I think, yeah, that's it on the housekeeping measures. Yeah. I would like to again say that if you have time and interest, you should visit this Tony Siba's presentation at RE Invest. It is worth taking a look at as we come from the field. So with these words, I mean, I would now request Mr. Mohit Acharya, a brief introduction of Mr. Mohit Acharya. He's a mechanical engineer with a specialization in energy systems. In Terry, he's mainly engaged in project consultancy activities in solar and other RE projects. He has significant experience in project management, feasibility assessment of RE, policy analysis, and working with government and intergovernmental organizations. Apart from technology development and demonstration, he's also involved in Terry's policy studies on RE. Currently, he's leading a floating solar PV consultancy activities of Terry. He was the lead author of which he will make a presentation. It's a very interesting presentation which talks about the potential for the entire country. I mean, that's the first of its kind. Prior to his joining Terry, he worked at the Interdisciplinary Center for Energy Research, ICR, and the Solar Energy Research Institute of India, and US project series at the Indian Institute of Science, Bangalore. He has co-developed a novel 3DOF mechanism to track the sun. His work has been published in peer-reviewed journal papers. He's also a certified energy manager from the Bureau of Energy Efficiency, Government of India. The floor is yours, Mr. Mohit.
Thank you, sir. Let me share my screen. So I hope that everyone is able to see the presentation slides on your screen.
Yes, yes.
And you can also see it on the full screen mode. Okay.
Yes, yes.
Okay. So thanks, Anilji, for a kind introduction. Now, before jumping to the today's presentation main topic, I just wanted to take this opportunity to introduce Terry. I know that Anilji has given a very brief introduction of Terry, but I just wanted to cover this as well in my presentation. So for those who won't be aware of what Terry exactly does, so Terry, the Energy and Research Institute, has been established in 1974, and since then we've been working with sustainable development of India and global south. We are based out of our headquarters in New Delhi, and has been our regional centers and campuses all across the cities like Gurgaon, Bangalore, Guwahati, Mumbai, Panji, and Nainital. The core activities which as an institute we cover is in policy advisory and outreach, technology products, and technical services. In Terry, the entire research and the policy advisory has been further divided into 7 different thematic research programs. Each has been leading by their program directors, and we have been supported by the support units which provides project management and day-to-day activities for the projects as well. We have been working or conducting research and outreach activity in across 50 countries as of now. In renewable energy sectors, we have been working in across the entire gambit of renewable energy, like starting from research and development, policy advocacy, regulatory advocacy, market supply and market and supply chain assessment, and so on. We have also few NABL accredited test and certification labs as well. Now, coming back to today's presentation, as I hope that till now you might be well aware of what is the floating solar PV, or as it is famously known as photovoltaics. So basically, from the figure, you can see that in this particular technology, the modules or PV panels has been installed at the floating platforms, which is known as floating pontoons or floaters. And apart from that, depending on the size of the projects and other, sometimes the inverter, in case of central inverters, they are also floated, or in case of other activities, anchoring and marine other. So you can see entire components of the floating solar, a typical floating solar plant over here. Now, coming back to why floating solar, the estimated potential of this particular technology has been measured at terawatt scale. Since it utilizes water surface, so it is considered as a land neutral, and as compared to the ground mounted or rooftop solar PV, it consumes or it requires very less amount of ground area. Typically, a 1 megawatt peak floating solar plant can save an area of about 1 hectare of land. Uh, uh, in the other part, as the vicinity, as the floating solar panels or PV modules has been mounted in the vicinity of the water surface, so cooling effect because of that can improve the energy yield out of the particular plant, and is been estimated at a range of 5 to 11%. Now, depending on its design and the type of technology of modules and other parameters that has been used, the different suppliers and the manufacturers are claiming different rate. Like Kyle and Terry has been claiming to achieve increase in energy production by 3 to 7%. In case of Banasagar Sagar, which we'll be visiting at the end of this presentation, or at the end of this day's presentation, has been claiming that a 9% increase in the energy yield, and 10 to 11% claim has been by the Yellow Troopers at their IOCL plant at Panipat. Also, as floating panels partially covers the water surface, so it has a potential to reduce the water evaporation loss. It yet to be proven practically, but theoretically you can save almost 1 meter cube of per megawatt peak of per megawatt peak. Also, there is a possibility of sharing the electrical infrastructures, like in case of irrigation dams, or in case of hydroelectric dams, if there are already existing substations or power evacuation facilities are there, one can use that. In case of hydro, particularly in case of a hydro power projects, it can complement the energy generation by providing the energy from floating solar plant in a day when sun shines, and shifting the energy generation from the hydro in the early morning and later evening peak time. It can also be looked at as a new source of revenue, as in case of a energy generation from this particular plant can be directly sold to the grid, and the revenue can be generated, or in other way it can be or the utilities who are installing this particular type of project can reduce their energy bills, and can get a saving from that. Globally, the technology has been reached a level of around 2 gigawatts of installation. So if you look more detailed analysis of that, out of these 2 gigawatts, majorly almost 94 to 95% has been there in India. has been installed in the Asia, which are again led by China, followed by Japan, South Korea, and Taiwan. The interesting point over is to note that earlier, when the technology is getting recognized in the earlier countries like Japan and China, the project capacity was in the range of less than 2 megawatt to 5 megawatt. But now the larger projects has been started coming up, and you can see this reference has been there in the Indian as well. These are the few companies who provides their services like project development or anchoring and moving supplies or floating structures for this particular technology. The major component of this particular technology, apart from the which are different from the ground mounted or typical rooftop PV plant, is addition of floating structures and anchoring and mooring. Apart from that, the PV modules, inverters, SCADA system, and transformer are all there in a typical solar power plant. Now, just to give you an idea about what type of floating platform which are being used in most of the projects right now, so it can be further categorized into 4 types. The pure float design, which is famously or which is majorly being used in the projects right now, is basically utilize especially designed buoyant bodies which supports the PV modules. You can see this particular type of technology in almost every projects which are coming right now. So there are different technology providers or suppliers for this. That is Hydro designed by Kyle and Terry. There is one more Japanese company who supplies. There is Sangro. There is one more Indian player like Yellow Tropers, who was previously supplying this kind of floaters. So moving into second type, in which the floating panels, solar modules has been mounted by using the metal structures and the pontoon. So basically, this kind of supporting structures has been came up in the uh, earlier days of this particular technology, and has been used in some of the few projects in Japan as well as in Netherlands and so on. So you can see over here that the solar modules has been mounted with the help of metal structure on the pontoons, which are used to provide the buoyancy force. The third type, and I could not refer as a floating, because in this case the entire floating solar panels in addition to the other component has been fixed to metal piles. Now this particular type provides a very good opportunity to co-locate floating solar panel or generating clean energy while co-locating with fish farms and other use of that particular water body. There are few projects which has been installed in China. The picture you can see is of 100 megawatt project in fish farm in China. The only difference over here is because of using the metal piles and the metal structure, the overall cost of the project may increase. But again, you have to choose that what is actual requirement of that particular project, and if the fishing which is happening at that particular water body is generating a lot of revenue, then in this way you can balance out the clean energy generation from that particular area, as well as also opens the revenue generation from the other sources as well. The last part is basically a membrane type or mat types, in which platform is been created by providing or by covering entire water surface with the help of rubber mats. Basically, this type of platforms, or I won't say platform, but this type of membrane type technology is particularly suitable where the water body is having a lesser area, and also in one like in case of industrial pond and so where you can cover the entire water body area. One what now jumping into since floating solar technology has been installed in the has been installed in the water surface. It is important to understand what role a water body has been playing, and what type of water body or what purpose of that particular water body. Again, it has been divided into further categories. Like first one, which are generally considered as a low-hanging fruit, is static kind of water body. These are particularly water storage reservoirs that are particularly used in the industrial or process it requirement, or in case of mining ponds or water treatment ponds. Since the surface area or the surface area of the water body is not very high, there is a very minimum effect of waves and current, and one can cover almost 80% of that particular 80% of the water surface area by the floating panels. Also, as the area is less, anchoring mooring is also relatively easy comparatively. The other type is the large water bodies, in which you can see the example like hydroelectric dams or irrigation reservoirs, in which risk is moderate. This is because the area of the water body is generally high, which and because of wind and wave and current effect, there could be a cyclic fatigue loop which is coming or which is coming at the floating panels and other. Also, there is a chances of water level variation and water depth variation. Again, one has to look at what is the distance from the shore, and one has to do thorough study of bathymetry and subsoil investigation. The other type is for near-shore seawater cases. These are particularly for near harbors or lagoons near the coastlines. Over here also the risk is moderate to high, and mainly because of the wind and the effect of tides and waves which are coming, and also if the lagoons or lagoons are near to the ship movement, then one has to consider the passing effect of ships and boats as well. Uh, the last one is offshore, which are particularly look at installing this type of technology at seawater. Till now, the only very few projects which are concept to commission in that stage has been coming up, and around in the range of 50 kilowatt to 100 kilowatt has been installed in few of the parts of the globe. And currently the research studies has been in underway, that how the longevity of the particular of this particular technology can be increased, particularly in these extreme environments. You can see few of the projects which has been installed across the various countries, like 150 megawatt in China, which is the largest plant has been installed in entire world, of around 150 megawatt. Coming back into the cost side, as we have seen in case of a ground mounted or rooftop system, the cost of floating solar technology is also being getting reduced as the technology getting mature. The interesting point to note here is that India is already been discovering the lower cost as compared to the other countries. Moving into the Indian standard, Indian status, till now the 9 megawatt of capacity has been installed, and almost 450 to 500 megawatt capacity are in the development or in pipeline stage. That are few of the tariff which has been discovered till now is in the last year for the Rihan Dam, that is for 150 megawatt, we have discovered tariff around 3.36 rupees, and in last year the Bihar Municipal Corporation has discovered tariff around 4.15 rupees. Recently, in the Andaman and Nicobar, India's first floating solar plus storage project has been came up, and it's has came up and is again the tariff or levelized cost of that particular was in the range of 7 to 8 rupees, if I remember correctly. Now, with the support from Energy Transition Commissions India, the TERI has undertaken a study in which we have looked at state-wise potential of solar technology. In which we have identified more than 2,000 large and medium reservoirs, and we have conducted thorough analysis that how much potential that can be possible for each and every reservoirs, and through this study we came up with a estimation of around 2 gigawatts of potential with can be achievable from this particular technology. The reservoir, the cumulative capacity of cumulative surface area of reservoirs is around 18,000 square kilometer, which we have identified. You can see the state-wise potential over here, which is led by the Maharashtra, Karnataka, Madhya Pradesh, Gujarat, and Rajasthan. It is again further, each and every reservoir has been divided, has been estimated under two different scenarios, in which each reservoir has been further categorized based on their purpose type. So in the next slide, on this slide, you can see that of each reservoir or all the 2,000 water bodies which we have identified has been further categorized based on their purpose type, and based on that we have given some threshold or some range to how much the water surface area that can be covered, and based on that we have come up with the potential numbers. The basic approach, I won't go into very much detail, because the approach, this particular approach has been well explained in the report which has been released earlier this year, and I request all of you to please go through that particular report, and you can see that what approach we have been used, and what type of actual project design steps that one has to take. Now coming into the project design guidelines, as compared to the ground-mounted projects, over here, I would say the feasibility stage or due diligence step is the most important one. The reason behind is that since there is a very limited know-how of this particular technology has been available, and also floating solar projects, particularly this type of projects, are more site dependent as compared to the ground mounted or rooftop system. So one need to do a thorough study of how the water surface area has been changing historically, what is the how the water depth has been changing, how the waves and current, if a reservoir is larger, how the waves and current profile of that particular reservoir is, what is the wind is what is the bottom topography of that particular patch of that of reservoir is. So one need to do a thorough study. It starts from first, if you consider any site, with the help of GIS softwares, one can identify that how the water surface area has been changing, and identify the patches of the suitable area where the floating solar panels can be installed. and once that particular patches has been identified, one can do a detailed bathymetry and hydrography study over there to find out the bottom topography. Once it is done, one can also do a thorough environment and social impact assessment, because we need to understand that each and every water body has its own ecosystem and is been used by the several has been used by the several. It can be used in the fishing. It can be used by the local biolife itself. So one need to do a thorough impact assessment for this particular technology to sustain a life cycle of around 20-25 years. So just give you an example that how a GIS-based study for before jumping into a straight or deciding that X megawatt of capacity can be installed. I have taken an example of Parambiculum reservoir, uh, uh, and one can see that. So image on the left hand side of your screen, you can see that the water surface or water coverage area has been changing throughout the last 5 to 6 years, and you can identify the patches where the water surface always presents. So from this type of analysis, you can select the suitable patches from the entire reservoir area. Once that patch has been selected, uh, you can go for the further study like bathymetry and hydrography, etc. So ultimately, from the GIS study, you need to find out uh, an optimal water surface area. If it is water reservoir is very large, then that patch should not be too far from the shore. Otherwise, it will increase the cabling cost and other component cost. It won't be too near to the shoreline. Otherwise, there might be chances of drying up in the lean season. So this kind of steps are required for or are much needed for to undertake this particular type of technology. Now once you have a like suppose I take an example, you have reservoir of around 100 square kilometer. Out of that 100 square kilometer, through GIS based study, you have identified 5 or 10 patch in the reservoir, surface, where you can see that water coverage is there almost entire in 10 to 15 years, and water depth is also in the range of 10 to 15 meters. So once you have that data with you, you can use the bathymetry study to find out what is the exact topography of waters of the bottom surface which is there in beneath the water surface. Now again, bathymetry has been done with two types of has been done with the two types of technology. That is, one is single beam and other is multi beam. Each has their own cost associated cost with them. So over here you can also approach or you can also devise a methodology that out of 5 or 6 patches you have identified, you can use first you can conduct a bathymetry study first with a single beam because it costs less. Once you have a better understanding of what is the exact profile of bottom topography over there, you can select 2 or 3 patches out of that 5 or 6 patches, and then on that selected 2 or 3 patches of maybe around 10 square kilometer out of 100 square kilometer, you can conduct a multi-beam eco sounder survey where you can which can which can provide you much better resolution, and which can be used at a later stage for designing your anchoring and mooring points and so on. Just to give you an example of how a bad or how an improper bathymetry survey could lead you or could leave you with, that is, you can see that in case uh, the the background research has not been done properly, it can puncture the floating panels at the time the reservoir gets drying up. So one has to do one has to do a thorough analysis for this kind of technology. The other important part that has been emphasized by the SS Mishra ji as well in his presentation is the plot size. We have to understand over here is in principle the initial design phases of floating solar PV projects are bit different compared to a ground mounted one. In ground mounted one, each row act as a single unit. So drag force because of wind has been lower as compared to what could be there in case of a floating panels, because each points or each joints has been interconnected, and it can act as a single unit. It act as a single plot. So the plot size plays a very important role over here. Larger the plot size can lead you with the high number of anchoring a mooring line, and can hamper at the time of cyclone or laguna. Even one part get damaged can uh, can reduce the entire project lifetime. So as per our analysis, we have found that project plot size of around 3 to 5 megawatt peak in one single is the ideal suitable one, in where the anchoring mooring lines is also or forces on the anchoring mooring line also get minimized. Just to give you a gist of what, in case of floating solar panel, what an EI study could look into. As we all know that each water body has its own biodiversity and its own uses. So we, in case of a larger floating solar projects, one need to do a thorough analysis of in case of a longer run of around 20 to 25 years, how that particular project will affect its local condition. What could be the water quality it can live with, whether in case of SDPU material, there might be chances of leaving the microplastics in the water bodies as well. So one has to look into that aspects as well. We have to also analyze in case of leaching from the materials, what kind of impact it can leave it there. So uh, uh, that's why in case of floating projects, EIA study has a major role to play as compared to the ground mounted or in case of other projects. Just coming or just summing up to my presentation, as I explained earlier, each and every activity in case of at feasibility stage can play a major cost drive or can hamper the overall life cycle of a floating solar. If one has not done the background research correctly, the entire cost of that of of the particular project can be a very high, and one or we as a technology provider has to consider into this fact. So in case of it requires to conduct a thorough bathymetry and bottom topography. We have to also consider the surface soil conditions, water depth and variation. Also need to be considered. Distance from the shore also need to be considered. Water quality, particularly salinity levels, wind speed at that particular site. So each and every this point has its own significance and has to be checked thoroughly. The important point to be considered here is floating PV technology is more location dependent and requires rigorous due diligence as compared to ground mounted or other IE technology. So since it is a starting days of this particular technology, we or I would request to not compare this with the ground mounted cost and or other renewable energy technology, because it has some leading or some lean period of understanding this particular technology. We at this point of time no one knows what could be its effect in the 20 or 25 years it could live with. So this kind of points has to be considered. Uh, just to give you a little bit of projects, as mentioned earlier, as a TERI, we generally uh, work with the multilaterals and other government organizations. And in some of the few projects, we are working with the World Bank, in which we are developing a database of around more than 200, more than 2000 water bodies, which we have found that can be feasible for installing a floating solar panel over here. And this database will be available at World Bank's Global Solar Atlas platform, and anyone can go at that particular website and can see what are the where this the plants where the plants can be installed, how much potential that is, what is the vicinity to transmission lines, so on and so forth. So with this, I stop my presentation over here. If anyone has any doubts or questions to be raised, I'm happy to answer uh, at this point of time, or I can also revert you back if you have more questions.
Thank you, Mr. Mohit Acharya, for a very, very comprehensive presentation and also for sticking to the time. And we can take about 2 or 3 questions. As somebody had suggested yesterday, we can also have the questions in the chat, and then Mr. Mohit can answer through the chat, or if somebody wants to unmute and ask a question, that's also acceptable to us. Please go ahead and put your questions to Mr. Mohit. Yeah, I can see the hands raised. Yeah, sure. Go ahead. Yeah, please.
Thank you very much, Mr. Mohit. This is Chandrasekhar. I have just one question. So when you identify a water body, so based on the experience of of your research, what is the time frame that you need to take into account in order to start off the projects? Or like, I don't know, 6 months or to 2 years or 3 years? Can you just share your experience on this one, please?
Yeah, could you please bit elaborate what do you mean by the time frame? You mean from the starting from the feasibility, or
Yes.
you?
Yeah,
Yeah,
yeah, starting from the initial site assessment to when you
sure.
can say, okay, we can go ahead with the project, so start off with
So,
it.
so it depends on the what type of data you have with you. So, in case I had given one example of one particular reservoir. In case you have the historical data of water level variation and water service of around 10 to 15 years with you, the feasibility stage can be completed in 1 month's time period. And once you have the feasibility stage, feasibility completed, you can go for with the bathymetry and hydrography study, which again depending on the how much surface area you would be surveying. So it can be again finished in 1 month or so. So it is as compared to a typical ground mounted project. The only difference over here is the a feasibility study, that is again a GIS based study, and again checking the historical database, and the bathymetry study, which requires some time. So it's again depending on case to case.
Okay, okay, thank you. So basically, it would be like 2 to 3 months, in order to.
Yeah, it's depend on the data you have, definitely. But in
Okay,
ideal case, it's 2 to 3 months. You can do it.
okay, okay. Good. Thank you very much.
Yeah, I can see Mr. Imran Siddhavatam. You want to ask a question from NPCIL? Your hand is raised, Mr. Imran. No. Okay.
I have one more question. Sorry, just a quick
Yeah,
one.
sure. Yeah,
So,
go ahead.
Mohit, I do not know. Do we need to consider any kind of a permits or anything else from the authorities or regulatories? Like from the environment assessment and this kind of stuff in order to go ahead, or it is just like you find a water body and then you can. Because I think this topic has not been touched up. So, can you throw some light on this one?
Sure, sure.
We got
So,
some updates.
yeah, so as of now, there is no binding requirement from the policy from the regulatory point, because solar projects or particularly renewable energy projects are being expanded from conducting the EIA study. But if you have to you have to check with the water department or pollution control department for their permission. So in that case, they because it involves water body and water reserve or a reservoir, they can ask for a EIA study. I hope I'm clear to you.
Yeah. Okay. Good. Yeah. Thank you.
Uh, yeah, this is Shakti Panda from NPCL. I have just one question to Mr. Acharya. Regarding this feasibility study or bathymetry study, so we all the times we need to go to some consultant for this. Yeah, our government has some agencies to do this kind of analysis. And second question is, does Terry have some kind of guidelines for this projects, how to do a feasibility study and all that? Thank you.
Sure. But yes, there are few consultants which are doing this kind of studies, particularly in case of a marine environment, and they are also offering their services to the floating for conducting the technical studies for the floating projects as well. There is no such list from MNRE or from other bodies who identifies this kind of consultancy bodies. On answering for your second question, in the report which I was referring to, we have provided an overview of what could be the basic project design guidelines which one need to be considered. So we have given an overview, but based on the specific requirement, we can provide service to you as well. So,
Okay, thanks. Okay.
So we can take one last question from Mr. Arindam Pal from MPCIL. Mr. Arindam Pal, go ahead.
Yeah, good afternoon. Actually, I have one question regarding the float structure, sir. Now, as you have said, each and every float structure has got its own environmental impact. So my question was, which kind of float structure normally is now being suggested in India, like thermoplastic or ferrocement, metal? Which one, in your opinion, would be more suitable in Indian context?
uh, um, uh, to answer your question, as of now, if you see, there is no such study which look into the effect of material for particularly for the Indian context. But we've been using particularly HDPE in our water pipes or in our other activities as well from quite a long. So we have a long history of using the HDPE material. Uh, but the only negative impact which I could see is, as Mr. Hans was also showing earlier yesterday, that the fatigue carrying capacity or fatigue load which can be there from the waves and current, there could be some limitations for using the STPV, and also there are high chances of leaving a microplastics in the water body. So so we have to. It's a very we are in a very early stage to recommend one particular type of material for the Indian context.
I understand. Thank you.
Yeah. Yeah. Thank you very much, Mr. Mohit Acharya. I think further questions can be either sent as an email because we have time issues. Thank you very much, Mohit, for your wonderful presentation and for responding to some of the queries. And if there are more queries, we'll come back to with emails and all that. So we'll move on to the next presentation by Mr. Vivek Jha. As I said, he has been working in the sector for the last 4 or 5 years, and he's quite well known in the topic, in the domain. Just a brief profile of Mr. Vivek Jha. He's an independent clean tech researcher with about 16 years of experience in the topics of energy access, energy policy reforms, grid connected and off-grid renewable energy, new and emerging technologies, and associated policies. His work is centered around conducting evidence-based research, program management, assessments, and evaluation related to different aspects of energy infrastructure, including technological innovations, governance, energy poverty, and social inclusion issues. Along with a deep understanding of socio-economic impacts of programs, he also undertakes in-depth financial analysis from a business sustainability perspective. He has worked in different work environments as a policy researcher in TERI, as a grassroots field implementation professional, and as a clean tech startup founder. He has made multiple keynote speeches. As I said, he was also one of our star speakers at the last study tour that we had to Wayanad. And he is an alumni of the School of Planning and Architecture in Delhi and has 6 publications in peer-reviewed journals. The floor is yours, Vivekji.
Thank you so much, Anilji, for the introduction, and very good afternoon to all the participants. I've been following Mohit's presentation, so Mohit has provided you with a lot of details on the subject, and I hope I can provide you with some justice moving on. Just give me a second. Let me just put up my slide. So I hope everybody can see the slides.
Yes, sir.
All right. Thank you so much for confirming. So Mohit has taken you through the course of the project, and I would, in this case, I would just like to focus a bit on go into a little more detail about what floating solar and what are the various technologies. I saw some of the questions that you had. I'll try and answer them during the course of the presentation. And also, I would like to focus on risks, bankability, and environmental consideration, some of which has been touched by Mohit, but some of which might be interesting for you as well. So coming back to the age-old question of why. Why do we need to do floating solar when we are getting such good rates at ground mounted? So recently we had a tender of about 1,000 megawatts, and the discovered tariff was 2 rupees. So with 2 rupees tariff, does it make sense for us to look at floating solar, which is still at about 3.5 rupees per unit? Well, it actually does. One, we have abundant amount of water bodies that are spread across India, and they are geographically spread. So they do not indicate that any grid instability can be caused, because they can be spread across, equitably spread across the country. Secondly, as the number of projects go up, the problem of land acquisition is going to become more severe. So even if we touch close to about 10 to 20% higher rates than ground mounted solar, I see floating solar as the king here, because the site identification, the installation is simpler as compared to ground mounted. Also, necessarily have evacuation structure which are connected to them. So once you have a site, necessarily within a range of about 4 or 5 or 6 kilometers, you're going to have a substation, so your evacuation becomes so much more easier. Also, there is no requirement of extensive land preparation, so to say, and one can the project cycle can be made to be very effective, depending on what is the efficacy of the contractors that are working there, and what is the efficacy of the data that you have that one has collected. Also, in India, land is scarce and we are a densely populated country. How much of land would we kind of give away for solar, which can be used for multiple other purposes? Well, there is a reality check that we need to do, because sometimes while expanding solar projects, we are also encroaching on fertile land, which should never be the case. So these are the push factors. The pull factors, as I'm sure you have heard it many times over, is that there are no shading losses. The dust accumulation is lesser as compared to your counterparts at ground mounted and rooftop. And the temperature, there is a definite gain to be got from evaporative cooling, and which can range anywhere between 5 to 10%, depending on what kind of structures you employ and what kind of weather conditions are there in the region. More than that, it can be very well integrated into the ecosystem. And in fact, if designed well, it can it does not need to isolate water-based livelihood activities such as fishing, but can be very well integrated along with that. In fact, in the Mekong Valley, there is an experiment that's going on where floating solar is they're trying to combine floating solar with the fish hatcheries so that you can get the best of both worlds there. And I'm sure there are a lot of cases that will come up in India as well, where floating solar should be and can be combined with water-based livelihoods. The other part is that there is a definite doubt or there is a definite concern that Mohit has emphasized, that because of coverage of a water body, there can be problems with the level of sunlight penetration or the level of dissolved oxygen. But these are things that can be designed for. So, for example, in order to enhance the dissolved oxygen levels, the floating solar power plants can be combined necessarily with large aerators. So with aeration, you can in fact improve the oxygen levels in the water body that can go and feed into the plants and the flora and fauna. Also with respect to sunlight penetration, the tenders as of today in India, they kind of say that maximum coverage from the structure within the area that you cover for a floating solar power plant should be 70%, and 30% of the area should be left free so that sunlight can penetrate. And with the use of glass-to-glass modules and other things, one can have a look at that as well. It has socio-cultural benefits. In fact, very recently, we are in talks with inland waterways where floating solar can double up in form of jetties and provide charging stations for running of electric boats. So that, to my mind, is another great business case for floating solar to come up, because as of today, a very limited portion of our freight movements happens through inland waterways. And if we are able to create an infrastructure of charging, then we can create electric-based mobility on inland waterways with the help of floating solar as well. I'll get into the cost bit in the next few slides. So where all can it be done? It can be done essentially wherever there is a water body. But if we target the most fertile areas first, then large dams, village ponds, lakes in urban local bodies, and reservoirs within industrial complexes. Now, within the point D, we have seen NTPC take the leadership, where NTPC um, has converted a lot of these thermal power plant reservoirs and thermal power plants as sites for floating solar. And this is the a very stark difference between the presentation that I gave last year and this year, because now we are seeing the completion of almost close to about 300 to 400 megawatts of plants from NTPC. And that will be a big win for the industry, because there'll be a lot of learnings that will come up along with such large projects. The lakes in urban local bodies, for example, Hyderabad has Hussain Sagar, which has problems of it being filthy because of a lot of sewage that gets dispatched into Hussain Sagar. So floating solar can play a role there as well, where it can not only provide power, but also help in improving the water quality in the lake. And of course, village ponds, we can look at multiple business cases where we can support our agricultural and farmer background with power from floating solar. So Narega, under Narega, about 1 lakh ponds have been created in India. Each of them are about 3 to 5 acres, which can deploy about 500 to 1 megawatt of plant, 500 kilowatt to 1 megawatt of floating solar power plants. So this will help, not only help in a reduction of evaporation losses from the ponds, but would also provide additional energy for a variety of needs that can be considered. As the report that Terry has done, the floating solar as a third pillar, that does a very detailed calculation of what is the market available. And also in the last presentation, Mohit has stressed about what is the importance of the surface coverage of a reservoir. So depending on how robust the ecology is, the surface coverage changes. So if it is a raw water reservoir in an industrial complex, we can go up to about 80% coverage. But because it has no ecosystem which is attached to it, but if we are looking at a lake, then 5% or 6 or 10% is the maximum that one should kind of go. These are so most of these now, after we have kind of identified, and most of you are from the from the tendering authority side. So it's important that where do we choose our sites? So these are a few pointers, more self-explanatory, but you can see them on the slide. But it's important to note that security is an important function. Secondly, it should be close to manufacturing facilities. So you should not a remote location. Getting there itself is going to be a huge challenge. And if it is closer to load centers and populations, then the energy can be utilized by those load centers. So one gets a better business case. In terms of weather and climate, areas should be chosen which should have calm water, preferably. There should be little or little winds or storm if possible. And if it's a reservoir which gets affected by drought, then this becomes an even more feasible solution. The shape of the water body in terms of water body characteristics should be regular. It should not be an extremely irregular shape. And if possible, the south side of the reservoir should be wider so that you can maximize the potential of deploying a floating solar power plant. And one should avoid areas where there is high terrain on either ends, because that will give shadow losses. And this is the case in our hilly regions where there are reservoirs, but one has to undertake analysis to analyze that how much shading losses can come because of the high terrain that exists. If possible, what reservoirs should have shallow depth. By shallow depth, I mean 10 or 20 meters to the max. We shouldn't attempt, or um, we can attempt reservoirs which are 90 meters or 100 meters deep. But what that'll do is that'll make the anchoring and mooring solutions extremely expensive, and the viability of the project itself might get questioned. More so, the areas that we choose should have decent soil bearing capacity, so that anchoring and mooring can be planned well, and the reservoir bed, as far as possible, should be clear of obstructions. So, for example, the Tehri Dam had submerged the old town of Tehri. Now, if we want to kind of do a floating solar power plant at Tehri Dam, one, the depth of Tehri Dam is almost about 100 meters. That has to be taken into account. And secondly, because the town was submerged, there would be a whole lot of obstructions that would be there on the reservoir bed. So one will have to keep that in mind. So low salinity water bodies would be preferred, and it should not be very far away from electric infrastructure, which in case of floating solar is an added advantage as compared to a ground mounted system. And plus, very importantly, there should be sufficient area which should be available close to the shore, where all your electrical equipments can be deployed. So you'll have the floating solar power plant in the reservoir, but you'll have extra electrical equipment such as transformers or inverters that would need to come on shore. So sufficient area should be available so that all of these equipments can be placed, and a regular evacuation system can be created. Now, what is a floating solar power plant? Well, there are multiple dimensions to floating solar power plant in terms of, they start with what is the material that we use. Should we use thermoplastic? Should we use ferrocement? Should we use FRP? So a whole lot of questions and a whole lot of ideas or concepts that kind of drive what kind of floating solar plants we need to build for the future. Now, later in the day, you'll be visiting a ferrocement plant. So it has its own advantages, as it's extremely stable, and it can withstand heavy storms and floods, but it is also extremely expensive and it's not scalable. In case of thermoplastic, it has its own sets of drawbacks, where I'm sure other people have spoken about it, where the joints, they crack under multiple cyclic loads, and thereby they are not the best fit. But whatever be the case, there is a lot of design work that needs to kind of go into the sector. And I'm sure as more and more projects come up and the competition intensifies within the sector, there'll be more design ideas that will come through. As of today, thermoplastic or HDPE is probably the most used material and has decent amount of buoyancy. There are multiple tests that are done on the material, which are a part of the tender specification. So that makes it to an extent safe, but things like joints and other things, that has to be looked at once again. Now, Mohit said that we need to conduct a bathymetric study, and he said that we can either do it from a single beam or a multi-beam. So here I'm showing you what a bathymetric map actually looks like in real life. So on the left-hand side, this is the area marked in red, was the area which was selected for bathymetry. And what you can see are the various contours underwater. And these contours, why is a bathymetric necessary? Because in a reservoir, we need to identify an area which has perennial water availability. Means the water should be available to a minimum depth of 1.5 to 2 meters throughout the year. It should not be the case that you identify a site and during the dry season that area gets exposed to the sun. that will have implications on the floating solar power plant. So once you conduct the bathymetry, it allows you to kind of create a DEM, or a digital elevation model, and based on which you can identify the area which has perennial water availability because of the FRL and MDDL of the reservoir levels, and also you can identify an area which is clear of any kind of obstructions. So once the bathymetry is done, so this is what the bathymetry map in terms of contours looks like. And this is what a bathymetry survey area in terms of a 3D representation looks like on the left and on the right. Also, what is very much required is something called a standard penetration test, which is done in case of ground mounted plants anyways. But here, the standard penetration test is done to kind of identify what is the soil bearing capacity of the reservoir bed. Because if I have to deploy an anchor which has to take a load of about 10 metric tons or 15 metric tons, then I better be sure that if I put a helical pile, the soil will not give away, or elsewise, all the efforts made into the project will go as a failure. So the soil studies and geotechnical studies, including standard penetration tests, become very important. These are important to choose what kind of anchoring mechanism that one deploys in the floating solar power plant. So here you see different types. So on the first two are what we call precursive earth-driven anchors or helical piles. And on the rightmost is a gravity anchor or a dead weight anchor. So depending on what is the loading that you have on a power plant, one can decide whether we use a gravity-based system or a pile. Now, let's say if if my loading comes to about 10 metric tons, as I said earlier, and if I decide to go with gravity anchors, the size, now density of concrete which is used is about 2,500 kg per meter cube. And as soon as it goes in water, the apparent weight of that anchor will become half. So if it is a 2-ton anchor in water, it'll have the holding capacity of only 1 ton, because a lot of it will be lost to buoyancy. So if we have to put up a 10 metric ton anchor, then we'll have to design a concrete structure which is 20 metric tons. 20 metric tons of concrete structure means that we'll have to design something which is 10 square meters, or which is quite humongous actually. So a 10 square meters, if you can imagine, is almost a 3 meter by 3 meter room and 1 meter high. So that is a huge structure to actually construct, A, and B, deploy in the field. So in that case, a better solution would be to go with a helical pile anchors, which can support up to about 25 metric tons and which have lower area that they use. This is also very important in areas which have a rich diversity of flora and fauna. And let's say if you're looking at Andaman or Lakshadweep, where there is a coral or and there is any sort of reservoir bed activity, then definitely a helical pile anchor would be the most suitable solution. These are the various ways in which a helical pile anchor can be deployed. This one that you see on the slide is called a manta ray and has a bearing capacity of almost about 3 metric tons to 30 metric tons. And this is on the right hand side, you see a typical anchoring and mooring solution. So it starts with the anchor, then you have the mooring chain, and then you have a dead weight to kind of tension the whole mooring arrangement or station keeping arrangement, as we call it. And then finally, it is connected to a buoy, which is finally connected to a floating solar power plant. So depending on the soil capacity, you decide which type of anchor you use and what will be the design of the anchor. So it is not one size fits all. Every site has its different requirements, and that will have to be calculated through geotechnical evaluations. Finally, once you have all this data, you've decided what kind of anchoring and mooring solution you'll put, then you design the layout. The layout, this is a typical layout for a plant. Here you can see a layout for a 3 megawatt, where all the red things are, all the red are your panels and the green are peripheral floats. Then, yeah, as the legend says, you have secondary mooring lines, primary mooring lines, you have a buoy, and you have an anchor or a fixed type. What other studies are essential, and this needs to be conducted from a design perspective, and this is typically what the developer or the EPC would do. So you will have to consider computational fluid dynamics to see what are the wind loads that are coming onto the floating solar power plant, and what, from which direction and how much, and then accordingly will you be able to come to a final figure of how you're anchoring and mooring, or what kind of floats that you need to design. Moving from there, once you have the data for geotechnical studies, the anchoring and mooring itself is done on pretty sophisticated softwares which have been developed by the marine industry over several years. So here, one of the softwares I give you the example of is OrcaFlex. And there are multiple softwares. There's ANSYS, there is Bentley, and so forth. These give you an idea of whether the yellow lines that you see, these are all mooring lines. And on the right hand side, it shows you a graph of the tension against time. So depending on the dynamic forcing, which can be due to waves, due to currents, or due to wind, the tension on the mooring line will differ. And accordingly, one will have to take their design the characteristics of it. Then finally, you come up to the final design of the anchoring and mooring. Also, while designing the anchoring and mooring system, you have to take into account two things. One is the water level variation, because in most of our reservoirs, during the shallow periods, the water levels will be low, and during the monsoon season, the water level will be high. So you have to take into account what is the water level variation. And also along with that, one has to keep in mind that your solar plant always needs to be south facing. Now, if you kind of leave a non-taut anchoring and mooring system, what will happen is, as the water level goes down, there will be flexibility that will be available in the mooring ropes, and the solar plant can change its orientation. The moment it changes its orientation, you will have a loss of energy generation. So that's why an anchoring and mooring system is important from multiple point of views. Probably more important than the actually even the float design is actually quite important. Let me not say that. This is another view. On the right hand side, you see a graph of what is the tension in the mooring lines as compared to different time zones based on the currents and waves in the water body. So these are pretty well-known techniques. As I said, also in earlier slide, the area then, once these studies are done, then you parallelly also have to locate an area where your assembly and storage of your floating power plant can happen. So a floating solar power plant essentially gets constructed on the ground, and then it is pushed into the water. So for on-ground assembly, you need an area. So here I have given you approximately about 2.5 to 3 square meters per kilowatt peak of area is required per megawatt of inventory that you want to keep. And also a clear area of almost about 200 meters by 20 meters is required for the assembly. So the more flat that terrain is, the better it is. So here on the left-hand side, you see that there is a site identification process that takes place where you kind of identify based on what is the terrain of the land, where you can easily assemble. This is the typical installation process. So on the left-hand side, you follow the cycle of putting the flotation devices. So from point number 1 to point number 5, different flotation devices are put together and they are fitted in. And on point number 6, you have when the solar panel goes on top of the flotation device. And then subsequently, once the entire plant is assembled on ground, then on the right hand side, you see how it's being pushed into the water body using a launch platform. A launch platform is pretty clear on slide on photographs number 2 and 3. And 4 is what a final floating solar power plant looks like once it's deployed in water. Now we come to the risks. Anilji, I have to, how much time do I have? Okay, never mind. According to my watch, I have another about 5 minutes, so I'll try and just hurry this up. Moving forward, there are multiple risks that are appreciable in a floating solar power plant. One is a value chain risk, because as Mohit said and as other speakers said, this is not a established industry. So from your design of floats to the actual deployment, there are multiple gaps in value chain that exist as of today. So one has to take that into account while planning for a project. So please don't give very short timelines and take contingencies into account while planning for a project, because as the industry is not very established, some processes may create a bottleneck and may take extra time. Also, there is a problem with multiple contractors which are available. As somebody asked that for hydrography, you have a different contractor. For bathymetric survey, you would have a different contractor. Plus, then for deployment, you would have a different contractor on land. For deployment in sea or in the water, you'll have a different contractor. So there are multiple contractors that exist today. So there is not one agency or contractor that will give you a turnkey solution. So it's important, again, to make sure that the process that you follow while designing the project and while executing the project is flawless, where multiple contractors can come and talk with each other and help in the design procedure. There are policy risks, as many of us are very aware. Andhra Pradesh was one example last year. There are resource risks, and here is pretty self-explanatory that what can be. The first one shows on the left shows what I was talking about, high terrain. And then there are mismatch losses because of waves and other factors. There can be other factors that one can take into account, that is soiling losses or long-term degradation, some of which are general to ground-mounted floating solar as well. There are regulatory or compliance risks. So I remember the government I think a couple of years back, Maharashtra was planning for a large floating solar power plant. But the moment this power plant was kind of announced, there was a lot of protest from the farmers. So an environmental and social impact assessment, though it might not be necessary as a regulatory procedure, but as a tendering authority or as a developer or even as an EPC, it's extremely important that you undertake it, because you don't want that you are 3 months or 4 months down into the project and suddenly some risk comes and shows itself, or some people start protesting. So all the communities and all the associated stakeholders need to be taken along while designing of the project. Otherwise, one will have problems while deploying the project itself and while maintaining the project. There are definite environmental risks. So most of them have been explained by earlier. Other things is something that we do not look at is on the top left side is the visual effect of a floating solar power plant. So if you're locating it close to an airport, then it should not be a very large, because you'll get a glare from the floating solar power plant, which might affect the flights that are coming in. Also, there are electromagnetic risks that are or risks because of electromagnetic fields which are associated with floating solar power plant, which needs to be taken into account. So, in summary, what I've tried to do is I've tried to give you a whole lot of risks which are associated. There are a few risks that I haven't talked about because of the paucity of time, but there are technology risks which some of you asked a question about. What kind of float should we take? What kind of anchoring mechanism should we kind of deploy? Construction risks. Is he the contractor who's doing the project? Are they an established contractor or not? Do they have the right track record? What are the operation and maintenance risks? How often do I need to look at the anchoring and mooring system? Once in 5 years or once every year? And what if there is a sudden storm? How will I maintain the plant? And finally, something that has not been talked about in policy circles is what is the decommissioning risk? We are putting up a lot of plastic in the water body, which is HDP. What happens 25 years down the line? Yeah, who is going to recycle the entire plant? Is the plastic which is used in the floating solar power plant being recycled by the developer, or it's being recycled by the component manufacturer, or it's being recycled by the tendering authority? So these are some questions and risks which are associated and which one has to see. Finally, I'll leave you with a bit of good news. So we did a plant at IOCL, which was an industrial under industrial water body, and we compared the the electricity generation to a rooftop plant which was in the vicinity of about 100 meters. And what we saw was within a period of about 4 months, we saw a gain of 8.3%. So this essentially means that if you design your project well and if the site conditions are right, you can get a definite gain from floating solar, and which means that the cost of floating solar can be 8.3% higher than the cost of your rooftop system and still be viable. So I'll leave you with that, and I would be very happy to take questions if there are any. And if not, then I hope that the presentation has been well received. And thank you so much for your time and patient listening.
Thank you, Mr. Vivek Jha, for a very comprehensive and detailed presentation on the different kinds of risks. Now the floor is open. Maybe some 3 questions to Vivek Jha. Do hands go up? I see one from NPCIL, or is it the old? Hello. Yeah, Mr. Arindam Paul, do you have a question?
Yes, sir. It was a wonderful presentation, sir. First of all, thank you so much for enlightening us. I have only one question. You mentioned about that this regulatory or compliance risk. So that raised a doubt in my mind. Can you please tell us about the typical approval, statutory approvals that may need to be taken for this kind of projects?
Okay. So the multiple things that needs to be taken into account before designing a project. Who is the owner of the water body? That's the #1 question. And what is the owner of the water body? What is the partnership that the tendering authority has with the owner of the water body? How are you kind of creating a system where the owner of the water body moves along with you in the project? So that's #1. #2, typically you have, as of today, as Mohit rightly said, we do not have any norms that you have to take these regulatory clearances. But as I mentioned during the presentation, that environmental and social risks need to be assessed before even starting with the project. Because what will happen is no government agency is going to come and pull you up. But you don't want a situation that you are 4 months down in the project and suddenly a group of protesters come and do not let you deploy the floating solar power plant. Or there is a notice from the central board you cause. So as there are no kind of compliances per se, but it's always good practice to do your ESIA. So your environmental social impact assessment needs to be undertaken. Apart from that, the regulatory, the other clearances that are there are with your inspector general for electricity, all your normal procedural clearances that you get from your local nodal agencies and so on and so forth. So those are the same in case of a floating solar power plant as well.
Thank you, Vivekji. There are two more hands going up. One from
Yes, sir.
HPCL. Yeah, go ahead. Yeah, introduce yourself and then put your question.
Yeah, this is Padam Narayan. I have one question regarding the concerns of multiple contractors engaged in the project. As sir has pointed out, there will be multiple contractors, and this is what the practice we are also facing, that the one party who is a principal contractor engages multiple contractors to do different tasks. But you rightly pointed out that there has to be some interaction, but these interactions usually do not encountered, I mean, as a practice, do not encounter during the conceptualization or maybe at the beginning of the project, because as we go on to the project site and as the time progresses, we engage different contractors to do certain work. How would you see that problem can be resolved in terms of making it more effective, because this is something which has some potential in terms of execution of a particular job, especially when you go about the anchoring and the erection of the other electrical equipment. How would you suggest that this philosophy or this process can be improved in the meantime?
Okay. It's actually a very pertinent question, and thank you. And with Seki, a lot of answers are with you only. But what I will try and specify here, I'll take an example. For example, you want to do anchoring and mooring in a particular reservoir. So there are different processes. Number one process is that you have to design the anchoring and mooring system. When you design the anchoring and mooring system, there is typically, as of today, a typical consultant will come in, who has knowledge of marine systems, and he'll come and design your anchoring and mooring solution depending on the geotechnical data that you provide. Now, these are pieces of paper that will be passed on to the EPC, and then the EPC will identify a different contractor who will go and deploy the system. What we have typically faced is the contractor or the subcontractor who's deploying the anchoring and mooring would say that I do not have the requisite equipments to actually deploy whatever you have designed. So number one, the best way forward is during the design period to all the contractors and subcontractors should talk to each other, because it should not be Chinese whispers that a person designs something and that cannot be executed, or the certain kind of equipment to execute the project does not even exist in India. So from the very beginning, the only way forward as of today is to have multiple discussions between all subcontractors. Identify your subcontractors very early in the project. Don't leave it till the last minute that, okay, we have to start our anchoring and mooring 6 months down the line. We'll identify a subcontractor 6 months down the line. To the extent possible, try and identify them right at the beginning of the project and have them sit along with the design team so that all these initial issues can be sorted out. Later, what I see the industry doing is pretty much as the number of projects will grow, I see more turnkey or more integrated contractors coming up. As of today, large EPCs or developers haven't put their in-house teams because the scale of projects is small. These problems will go away as the scale of projects will grow, and you'll have developers and EPCs who will start making their in-house teams for anchoring and mooring and for other specialized equipment, that you require in a floating solar power plant. I hope this answers your question, Padam.
Yeah, Mr. Padam Narayan. I think he's muted.
Yeah. Sorry, I was mute, sir. I'm sorry. Yeah. So thank you very much for the response, sir. I mean, we take your advice in a proper direction so that the engagement of subcontractors can be done at the very primitive stage, so as to have a comprehensive idea while we kick off for the project execution itself. Thank you very much, sir.
Pleasure.
Thank you. One last question, if there is one, or else I would say thank you, Mr. Vivek Jha. Can I see if there is some hand going up? No. All right. Okay. We are on time. We are on schedule. There is no coffee break or a tea break. Thank you, Mr. Vivek Jha, for a very wonderful presentation. And definitely we'll bother you if there are more participants like that. And then we look forward to receiving responses to that. Thank you, Mr. Vivek Jha.
And it was a pleasure. And you've been a very nice audience. Thank you. Bye.
Thank you. Thank you. Bye. Bye. Thank you. Okay, we move on to the last but not the least presentation. This is the virtual plant visit to Banasura Sagar Dam, 500 kWp floating plant owned by the KSCB. Mr. K. Ayub, the executive engineer at the KSCB, will be making a presentation. Let me give a brief profile of Mr. Ayub. He holds a master's degree in electrical engineering from the National Institute of Technology, Calicut. He has worked with the Larsen and Toubro as a production engineer. He was a consultant at Mott MacDonald. He has also worked abroad in Qatar Electricity as a production design specialist. He has about 10 years overseas experience, and he has been with KSCB for 13 years. In the Kerala State Electricity Board, he has been mainly in the transmission and distribution. And currently, he is leading the KSCB rooftop power plants in the northern region as project manager. Mr. Ayub, the floor is yours. Thank you.
Thank you, Mr. Anil. I'm audible?
Yes, you are audible. Yeah.
Okay. Good afternoon, everybody. Today we have had, I think, enough of theory part of floating solars, and I plan to take you to the virtual tour. Before that, I just give you a brief idea of the plant. This was our first plant, this floating solar, and it was 500 kilowatt peak. And it was commissioned in the year 2017. And when it was commissioned, it was the highest plant in India, a floating solar plant in India. And the peculiarity of this plant is that this float is made up of ferrocement. And this was also our power evac. The conversion has been done in the float itself. That is the peculiarity of this plant. And this is in the and it's in the Kabini reservoir, where we have the hydroelectric project reservoir, and we use that space for this plant. I think I'll go to the virtual tour. After that, I'll come back and discuss about what we learned from this project. We also had another rooftop, dam top plant near to the floating solar, so that we could do a comparative study of the energy produced. That result also I will be presenting. So I'll move on to the presentations.
Good afternoon. On behalf of Kerala State Electricity Board, I welcome you all to the virtual tour of Banasura Sagar floating power plant. And here, before I move to the plant, I request my colleague, Mr. Anil, who is looking after this dam, to give an introduction about this dam and all. And after that, we will move to the actual location where we are all eagerly waiting for. Welcome to all. The floating solar power plant 500 kWh, which is the largest one in India when it is commissioned in 2017. This plant is located in Kutyadi Augmentation Reservoir, which is commonly known as Banasura Sagar Dam. Before moving to the plant, we just discuss about the common technical features of this dam and augmentation scheme, commonly known as Banasura Sagar Dam, which is situated in Karaman Todu, which is the largest tributary of Kabani River, which is flowing through Kerala, Karnataka and Tamil Nadu, then finally ends in Bay of Bengal, which is the second largest monolithic earthen dam in Asia. It is the second largest one in Asia. Welcome you all to the 500 kilowatt Banasura Sagar floating power plant. I'll quickly move to the complete plant, wherein we are standing in front of the panels. We have just to give you the idea, we have totally 17 floats, which is made up of ferro cement, on which our plants are located. And this every plant we have approximately 23 in series, and this 23 modules, and we have one module, one string has got 23 modules, and like that we have 5 strings connected, and these 5 strings are connected to a string inverter. After that, from this string inverter it goes to the AC panel. From the AC panel we have another transformer. Then it is stepping up to the 11 kV level, and from 11 kV level it goes to the our grid. This is the basic idea of our plant. We are now moving on this floating panel. You can see this. This is actually our ferrocement plants, and it is very stable compared to other HTP and all. This is very stable. That is what we found. And just like we are moving on a normal land, that is the advantage of this ferrocement, where we have no vibration at all. And whatever the energy, this solar plant, we should have the complete, if it is vibration free, then we will get the complete output. That is it. That is advantage of this plant. Also, what I wanted to show is this water, this plant is placed over the water body, so that it is directly, the cooling effect is direct. So the plant is getting cooled. This is one of the advantage of placing our panels or floating solar. This is the design. We have you can see this water, and above which our panels are there, so that the temperature of the panels is coming down. So basically, we know that the output voltage of this, or output power, is directly proportional to its temperature of the modules. So temperature is less when it is placed over the water. This is the design here. Let's move quickly to the next inverters. I already told these are the modules. and we have 23 modules connected in series, and like that we have 5 strings. One string has got 23 modules, and then we have similar 5 strings, all are connected to one inverter, string inverter of capacity 30 kilowatt. Let's move to one inverter and we'll see the inverter. Then we'll move on to the control panel. Yes, this is our earthing strip, and this earthing strip is actually in every float. It is surrounded in the water, and this earth is actually we are taking this earth and we are directly connecting this earth to remote. We are not putting this down and earthing it here. We are taking this earth completely, and then we are earthing it at the remote shore. This is how earthing is done. I'll explain it when we reach the plant. You can see the gap between these two floats. This is, as you all know, that the solar plant is to be placed facing the south, and this angle is approximately 15 degree here. As per our design, it is approximately 15 degrees. This also you can see here. I think the structure also, you can see this structure. Structure is there. This is a structure part on which the panels are placed. And this is, as I have already told, this is over the water body, so that the panel is cooling down because of this water. One more thing I wanted to say. If we can place water, that is what literature says, if you can sprinkle water in one way or the other, then the temperature of this panel will go down, which will in fact will improve the efficiency of the plant. This is what we are also planning on an experimental basis. We have to put some water on continuously or sprinkling or whatever the way we have to try in this, and we are planning to do that and to increase the efficiency of the plant. The water will be coming throughout so that temperature will come down. When temperature is less, then you can see that our efficiency will be going up. This is our main central plot. I have already told that we have 17 floats, and apart from the 17 separate floats, we have the single central float on which our control panel and SCADA system as well as transformer, everything is placed. The peculiarity of this plant is that the DC to AC conversion is done in this plant itself, so that we are evacuating AC from here, not DC. DC is only coming up to this point from the complete this thing floats. It is being brought to the inverters. From inverters, inverter of course will convert DC to AC. Then that we have the inverter here. CBIP make inverter. From inverter it goes to the AC control. From where we have a transformer which will come later, and then it is going to the nearby shore where we connected to the grid. This is our inverter. This is a string inverter. This is a string inverter of 30 kVA ABB make. I don't want to go in detail to the inverters and all, because difference between floating solar inverter or normal inverter which we place in the land-based solar plant. So this is the same thing. The only thing is it is a string inverter with a single input like 1 MPPT. Let us move to the panels. This is AC panel, you can see here, and all this inverter output is coming to this HRC fuses. For every inverter you have these are the 3 phases you can see here, and it is connected to our HRC fuse. From HRC fuse it's coming to breaker. You have 2 sets here. This half of these inverters are coming here, and the rest half is coming over here. You can see here. These are the ones, and from here it comes to the your circuit breaker, LV circuit breaker. We have relays also connected for the AC side. We have relays, we have overcurrent relays as well as earth fault relays here. Also, we have the voltmeters and ammeters, which shows the actual power and all. Apart from this, we have SCADA, which gives you the accurate power details. Let us move to the HV side. As I have told, the peculiarity of this plant is that the conversion from DC to AC, that is being done here itself, and from here the voltage is also being stepped up to 11 kV. That is 415 volt is step up to 11 kV here. Let's go to the transformer where it is being stepped up. Moving on to transformer. This is our transformer, and this is a 415 to 11 kV transformer, and we are connecting the LV side star and earth, and HV side it is delta connected. This is the way it's been connected, and you can see the earthing here. This is earth point, and this earth is actually directly taken to the shore through the separate earthing cable. We have used earthing cable itself. This is about earthing. The reason for taking this to the shore is that we wanted we do not want any earth fault current to flow through any fault site. We don't want any potential to rise here or anything during a fault. So we have designed in such a way that all the fault current will be directly going to the shore there. That is as if we have brought that earth here directly, so that we will not have any health hazards during or voltage issues when we have faults in the 11 kV system, because 11 kV system is coming. Another thing is, the main thing is the evacuation cable that you can see here. This is our evacuation cable. It's coming out from the transformer. It is 11 kV evacuation cable. This is specially made for this usage in this water. This cable, through this cable, it is going through the water. From this water, it is going to the structure there, 11 kV structure, through which it is being evacuated. You can also see here. This is our cable management system. But we call it as cable management system, because you know that when water is here, during summer season water will go down, and when during a rainy season, monsoon season, water will rise up, so that variation will take care in this using this system. This is actually some pulley system is here, and it is used that. You can understand that when water is going up, naturally this has to be, when it is going up, a cable has to be more there in the water, and when it is when the water is going down during a summer season, then cable will be more on the float. That is the way it is being done. I think we can move on to our SCADA system, where our power evacuation and water radiation, all these elements are monitored over there. We can also see the PR, performance ratio of the plant. Everything is monitored in our SCADA system. That we will move. Okay, well, we are in front of our SCADA monitoring system, wherein you can see here. This you can show. This is now showing today's export as 1077 units so far. Now its time is 12 noon. Approximately 1000 units have been added to the grid, and you can see the yesterday's actually 1921. You know that our plant capacity is around 500 kilowatt, so it's approximately generating. So far it is 4 units. So it is 4 units into per kW 4 units means it's approximately 2000. That's the way. The season is not completely, intermittent rains are here maybe, and clouds may be there. That's why the generation is little bit down here. We can see performance ratio, then savings in rupees, carbon emissions, everything is here. Apart from that, we have device monitoring, wherein we can see the inverters. All inverters are here, and its capacity and its generation, its healthiness, everything is shown here. Then we have weather station here. Weather station will give you the module temperature, ambient temperature, the rainfall, all those things, wind direction, everything is here. and then you have reports also, executive reports, or whatever the way you want your report to be printed. All those things are available here. And I think regarding SCADA, we have nothing more. This is, I think I have covered almost all in this SCADA. This thing also, we have this radiance data is also there. Yes, we have active power, current, then radiance data, everything is available. Whatever we need for this monitoring this our plant, everything is available. Also AC power and reactive power and active power both are available. Everything is available in the SCADA panel. I think with this we can close the SCADA, and we have to move on to the next part. Is I wanted to ask my colleague to civil engineer, our Anil. He will be presenting regarding this, how this float is placed in position. I mean to say, what is the anchoring is used, how here it has got concrete slab under this, on kind of bigger slab. Then it has got some C-flex brand anchoring system. This is what is there, and that is holding this plant in position. And Mr. Anil, he will be explaining how this ferrocement, how they have constructed this ferrocement, how it is brought in. All this will be he will be explaining this.
Actually, I am explaining about the construction method we used here. Actually, we have constructed this platform in two ways. One, this is when we are this is the main platform, that is called mother platform. The platform which is the solar panels are installed. It is actually not unlike the design of mother platform. It is like a ladder type design. The ladder type design, you can see the reservoir inside. It is actually the reservoir, not a pond. It is actually a reservoir. That reservoir, as Ayub sir earlier said, it gives the more efficiency to the panel. Now I will explain the construction method, how we are constructed the platform. Actually, this is a floating platform. Inside it is hollow. You can see that. I will show you that. Inside the platform is hollow, and only 2 centimeter 20 mm 2 centimeter wall is there. Bottom 4 side walls, then top cover. It is also a small concrete wall. Actually, this concrete is made up of ferrocement concrete. The concrete is reinforced with 3 type of reinforcement. One wire mesh, second chicken mesh, then inside 6 mm rods are there as temperature reinforcement. That is the peculiarity. Then every pieces are separately constructed, then jointed. The sides and top is jointed afterwards. That is the method of construction. Before conclusion, I show you, because for the safety of this plant, actually this plant is designed based on wind velocity. One additional security feature for this mother platform and the other platforms are, when any possible ingress, to avoid that, we are just marking some lines inside the outside the platform, 3 lines. Continuously we are monitoring the water level of the float. Then we are bailing out water with the pump. That is the additional features we have provided here.
I think we have completed our virtual tour to the Banasura Sagar. Hope you have enjoyed the place. It's one of a beautiful place in Kerala. It's also a tourist destination where people can come and stay for one day and enjoy boating. All facilities are here, and I will continue with my presentation.
Ayub sir, can I just intervene for a minute or two?
Yes, please.
Yeah. Thank you very much, Ayub sir, for a very, very professionally done video. I mean, it's amazing the way both you and Anil sir have put the voice, and the shooting has been extremely professionally done. I mean, it's really beautiful. I mean, I was reminded of our visit way back in March 2018. Sorry, 19. It's really nice. Yeah.
Yes,
Thank you very much. Yeah, please go ahead with your presentation.
Thank you, Anil sir. It gives us more pleasure as well as encouragement to do more. My presentation is now visible.
Yes, sir.
Okay. Thank you. So this is all what we have seen. I do not want to go much. Now we will see what are the important points what I can talk regarding this floating solar power plant. At present, I am not working with this. It's now 2-3 years over. Still, it's in memories, and I'm in now rooftop solar plants in Kerala. Anyway, this was and in fact one point to be noted is we have started thinking about this floating solar power plants in the year 2013, and some students from engineering college near Wayanad has come up with some floating solution with the ferrocement floats that later on we have taken up, and that small this is also you can see that is during the presentation also, we could not mention it, but that was there near to our plant, and based on that plant it was a 10 kW plant, and that was successful. Then we have gone to the 500 kilowatt project using ferrocement, and to mention that we had the worst ever floods in consecutively 2 years, and we were I see, in fact we should have taken some photographs or video to show to the world that it is the plant has actually I mean successfully stood in this what do you call this flood situation. I don't want to go to methodology and all. It's been discussed a lot. Now, why floating solars? Everybody discussed, and it is almost same point, but still a little bit of different thought. See, fossil fuel-based plants requires less space as well as energy produced is continuously available. In order to replace the fossil fuel-based means in the sense normal plants with nuclear plants or gas or this diesel plants or whatever, or coal, whatever. So in order to replace the fossil fuel or nuclear power plants with that of renewable energy sources like solar power or wind power, we need to address two distinct problems. The problems are large land area required for the solar power plant compared to the conventional plants. That's the first problem to be addressed. And the next problem is the storage issue of the solar power plants as compared to the conventional plants. A viable and practical solution for the availability of land can be solved if the floating power plants are used instead of land-based plants. That is the advantage of using. It's been told in one way or the other way by the other speakers in this. Still, Floating power plants can be installed in a variety of locations like lake, abandoned mains, all these things, large artificial basins, and all these things have been talked. Sea water is another possibility, but the use of sea is challenging, associated with heavy tides, salt corrosion, as well as power evacuation compared to other locations. The issue of storage, which is a common issue of all renewable energy, but floating solar plants with pumped storage plant is an ideal solution for the storage of electricity. This is what is that is the core of this presentation, where if you use the pumped storage plant with the floating plants, then the water that can be used, the day hours that can be pumped in the pumped storage plant and can be used in the night hours. Hence, the new PV system near our integrated and equipped with appropriate storage systems, they will merge smoothly into the existing structures with a minimum environmental impact. And now the floating power plant requirements, I just go quickly. This should have modularity. Modular structure must be built either the location or at remote place. In our project, we have done it at the same place where we have same shore. We have done this, and we have transported that through water to the exact place. Flexibility sector should be modified to implement cooling system, tracking apparatus, robustness. Floating system shall be designed to withstand wind speed, wave tides, water current, safety, personnel, optimal raft size for easy transportation, minimal cost. That is the final, but the most important part is the cost of this. Then I don't want to go in detail to the salient features, and all has been taken by other speakers. But to say this, see, you have some points. I think it's may not discussed so far. That is, if you use tracking of the floating solar power plant, it's more easier compared to land-based plants, and the energy gain is approximately 15 to 20%, 25%. All other points have been discussed with others. Discussed already by the other speakers. I don't want to. And another is reflector and gray energy. With reduced cost of tracking system in floating power plant, the use of concentrator for reflected energy is more economical, which in turn increases the efficiency of the plant. That is the concentrator, which with which we can the light waves can be concentrated and towards the solar plants. It can be directed. That is more economical. That is what literature says. Now we go to the major component of the Banasira Sagar floating power plant. Float is made up of ferrocement plant, and the mooring and anchoring system is there. Discuss how it has been done. Then modules, string inverter, all these things are there in all the panels. I don't want to discuss that. Earthing and lighting, weather monitoring, so all these things are there in all other things. The important part is that the platform is made up of float, ferrocement float. Then mooring and anchoring system is there. How to keep the ferrocement float in place. And another important point is regarding the grid integration of the generated energy, grid integration, and how we have. And of course, as everybody has told, there is no standard procedure, or so far we have not evolved to a standard system on which is the best possible floating power plant. Whether we can go with the plant with land-based this thing, transformer and all, or we can place it in the float. In fact, we have placed it in the float because our floats are very stable, because we have gone ahead with ferrocement floats. Even though it was costly, the important the point we have noticed is there is no fluctuation at all. Absolutely, because last time when people have visited, they would be remembering it. It's absolutely like a land-based plant, so that there is no vibration or anything like that. So it is also capable of having more capacity, so that see, even if you want to increase the capacity of the transformer later on, then you can take out the transformer and place another transformer which is of more capacity and of course with more weight and all. So that was another possibility with that. And of course we know, see, this was when we have done this, it is not as normally without much planning. And, we wanted to say that it was not much without planning, that this was a research and innovation project, so we have gone ahead with this. And as and when problems came, we have tried to solve the issues. I'll come to some of the problems what we have faced during the plant commissioning. And as I already told, there are 17 platforms made of ferrocement, which is used for placing the solar panels and inverters. Center platform for the substation, control room, and SCADA system. The float is held in place by C-flex mooring and anchoring system. The total area of the float is 1.23 acres. That is another point to be discussed. And compared to the land-based one, this is a 500 kilowatt. It takes only 1.23 acres. Also, what we wanted to say is the modules what we used was, at that time it was only 260 watts per module. But now the modules have come with this even up to 500 watts per module. That means I think the area can be even reduced to half. So people have to think about, the people who are there in the design side should be thinking about this. The float size is going to be comparatively, relatively going to be less. Even it is going to be half of that of what we have made. 1.23 acres. That means compared to the land-based one, it takes for a 500 kilowatt. It takes approximately 2 to 2.5 acres. That is what the experience. Construction of ferrocement platform, as Anil has already discussed about how it has been made. Ferrocement platform is made up of cement mortar and sand and with wire mesh, and it is constructed in site at shore. The location decided the float were to be. That is what this is all. Other speakers have already discussed. Hydrographic survey that has been done to identify the location where we can place the float, because you should be seeing what is the water level and what we call the statistics of water over past 10 to 15 years to find out that the level of what is the variation in water level, so that now we can design our anchoring and mooring system and all. That was what has been done by hydrographic survey. Also, we'll come to that. This is the plan we have seen. I just show you some picture of this. This is the ferrocement float platform, which is being made near the shore, and it is the photograph showing the construction stage. And I'll come to the mooring and anchoring system. This is the basic mooring and anchoring system. The system is used to keep the float in position against external forces and water level variations. That is what has been done. This project uses, as I think Mr. Franco has already mentioned, C-flex. C-flex is it is Swedish company. It is a Swedish company. I forgot this. Swedish company. That company has done the design for the C-flex, and it is for mooring, adjusting for water level changes while also taking care of forces. That is what has been done. You can see the photograph of this. You can see here. I'll take my pointer. See, this is the concrete block. This is actually placed in the bottom of the water. Approximately 6 tons of weight. This is made in the shore, and it is transported. Transportation was very, very exciting. Unfortunately, we don't have a video of that. It was brought to the place where it is actually should be. It was transported over a balloon in the water from the shore to the place, and when it reached the exact place, then what they did is they just broken the balloon, and it has gone and stayed in the place where it should be. This is the way. Then you can see C-flex here. This is a C-flex, and what it does is it is the adjustment, because water level is going up and down. So this gives you the adjustment. This is a rope like this, you can see there, here it is written ropes, and this is the platform. This is the idea of mooring and anchoring. And the technical details, maximum wind speed, the wind speed is 32 meters per second, and 10 meter height for the wind speed. That is normally what literature says, that height of the wind to be considered while designing this. And 32 meter per second, I think it is 115 kilometer per hour. That is the maximum the wind speed that is considered. Depth at lowest water level 15 meter. And the water level variation. Water level variation is, you can see here, 20 meter approximately, water level variation. And wave height is 0.3 meter. And water current is not being considered here, because it's a very reservoir where there is not much water flow. Methodology for calculating the forces acting on the flexible C-flux mooring system. The method based on British standard actually. Force due to wind, that is the first force that has been considered. Wind forces are considered 10 meters above the ground. Then forces due to waves. Then forces due to current, not considered in this project. This is normally what they consider, but the current is not being considered here, because the current is here very, very less. Then, as Cha has pointed out, there are a lot of this software application programs which are used for finding out the design, which type of C-flux they wanted to use. So the system is based on British standard, and below is a short summary. Dimension parameters, the structures of the floating systems are first set. How to do it actually? Determine the total exposed area. The wind pressure is calculated. The wind pressure together with the total exposed area gives the wind force acting on the structure. The total horizontal force acting on the structure is calculated as the sum of wind forces. This is important. Wind forces and other added extra force, wave and current forces. This is the idea. The force in mooring system is calculated from the total force. Type and amount of C-flux is determined. That is how they do the design calculation. It's a brief idea of how they do it. And this is the actual final layout of our system. You can see our float here. This is our float, and this is the first one, A1, and you have A2 here. You can see A2 here. This is all the position of the anchoring, that concrete block where has been placed. This is based on they did it, and they found the area, and they found out what is the type of C-flux that is to be used in area. To give you an exposure of what is to be done or what is being done when the float is to be placed in a place. This is what is the idea of this. Then placement of PV panels. This is I come to the plant again. This is we have already explained. This is placed over the water, and that is we have discussed. And this is about the electrical diagram. Electrical diagram is this. You can see there is no much difference actually. This is our panels. Like that, you have, this is one float, and you have like 17 floats, and one is having an approximate capacity of 30 kVA, and then maybe the string inverters are there. Then it is going to a bus, then LVCB or current relay, then it is a transformer, and to the grid. And this is a specification of the PV module. I don't want to go in details. Configuration of PV modules. This is also not much importance now, because there is no much difference. 11 kV substation and grid integration, grid connectivity. This is it's a different thing, and it is not normally seen in the plant in the float, because we had sufficient capacity in the float. We have gone for that. This is the advantage of less, because the voltage itself is converted into high voltage like 11 kV, so that the losses are minimized in this case. That is advantage of this. Of course, you will have one way advantage, or the other way it may go in the other way. It is different. But here we had that advantage. The 11 kV substation with 415 bar 11 kV, 500 kVA star delta power transformer is placed on the central platform grid in synchronization done in the float. Power from the float is evacuated to shore through 11 kV XLPE power cable specially designed for the application. Because the special design is the water resistant. That is what the cable manufacturer says. It is water resistant. It's not marine cable. Basically, marine cable is not being used. Net metering is there itself. Then cable management system we have already discussed. I don't want to go in detail. String inverter, that is also technical details which I don't want to go. Earthing challenges. This is another important point which we wanted to see. When we have placed the transformer in the float, we had a big challenge. Like, see, when there is a 11 kV fault, the fault current is going to. Initial design was the initial design which the consultant has given was marine earthing, the current to pass through the water and back to the shore. But as you know that even the LV voltage is making the dangers to the human life. We have thought it is not okay to go ahead with such an earthing system. So we have thought about what is to be done. And we know that see, when there is a fault, it's just like an earth, our this platform. So current is going to go, the potential is going to rise, step potential is going to come, this touch potential is going to come, so that the people who are standing on the top of the flat platform is going to be in danger. So we wanted to avoid all those things. So what we did is, finally we have come to a conclusion. Like, we take the insulated cables that we have shown in the presentation, the virtual tour. Insulated cable we have taken and directly connected this to the shore. That is so that current there is no point of current rising. Voltage rising in the float. That is what is the. We have done some calculation to find out what is going to be the voltage rise, whether it is meeting the requirement to avoid the dangers when there is a step potential. All those things have been calculated, and of course for this we have there is, as everybody has told, we were searching for standards, what to do with such a thing. We were searching for standards because see, as a utility, we are not a research team. We have to have something in front of us to follow. That was what we had the challenge, whether we can go ahead with this. And yes, you know, the seawater is not seawater. The reservoir water is more dangerous than the seawater because its resistivity is more than that of seawater, and the danger of getting electrocuted in a reservoir water or a clean water is very much higher than that in the seawater. So we had that issue in mind. So we wanted to go for, and finally we got one IEEE 888. This is 8005-1. The earthing method to be followed while ship takes short stay in the port and take power supply from the shore. That is what we have ended up actually. Ship, when it is in the short stay in the port, and to avoid environmental pollution, they take power from the shore. So that time there's an earthing method followed. That is the same method we have followed. In addition, what they say is, see, if there is a earth discontinuity, then we are in danger actually. So you should be always continuously checking the earthing, but this is not being done in our plant. Actually, we should be continuously checking our plant using our SCADA system or not, or like. And if there is any breakage, then the power should be cut off. That is what the standard says. This is what has been done in the during our design. Then SCADA system, of course, I had talked about. Then I go to the comparison of floating solar and dam top solar, because we had the opportunity. We had a dam top solar which you would have seen. I could not mention it because this is the first time we are doing such a virtual tour. Maybe next time we will make it more better. And what has been dam tops, where we started our journey was in the dam top. Then we went to the sea and reservoir, and then to the float. So what we could see is I have taken just for a 1 week data, just for curiosity, 1 week data we have taken, and we found that more than 5% change. That's the average change. I have not found out, maybe around 6 to 7% total change. That's what Mr. Jha also said. He has got 8% change. We have got, it is in the same place. It is like so we have done that study, and we have found out that it is the energy, because it is the similar type of this thing modules. It is polycrystalline modules, same types and similar time. I mean, same time it is commission on 1 or 2 years difference, and we have found out that this is the advantage what we have got. Comparison, relay and protection, of course, that is all. There is no much difference. If you know this, it's apart from the whether it is land-based or whether it is floating. Your relay is going to have effect on when you have renewables in the system, because this renewable current is going to come in your fault current, and the coordination time, when we talk about the overcurrent relays, the coordination time will be lost. That calculation is to be done when you integrate, basically when you integrate to LV systems. You have to calculate this. That is the coordination relays are lost because of the current which is coming out from the solar plant. Also, we know that the solar plant is not producing any fault-like current. It is only a load current, because it is acting just like a current source. There is no much difference between the load current as well as the fault current, but still there is going to be effect, and if the coordination time delay is going to be lesser and lesser, you will have coordination problem with the relays. That is one of the problem with the LV side. When you go to the HV side, you have maloperation of distance relays as well as your directional relays. That is what is the study says. Distance relays, of course, distance relays, if you have a foreign current which is coming, then naturally you'll have underreaching, overreaching based on the direction of the current. That is one thing. And this is what the solution they say is better to go for the line differential relays. Maybe we will have the challenges on relays and protection, and later stage we will take it up. I just wanted to mention in this time, that's all. Now I'll go to the conclusion quickly. It's being details of just read out what is so that I need not lose any points. Details of the floating power plant and its installation on the ferrocement board has been discussed in this report. The solar plant and the 11 kV substation are placed over the ferrocement platform, and the DC to AC conversion is done as the plant itself, as a result of which there is savings in the cost of DC cable. As the power is converted to MV 11 kV alternating current, power loss is reduced in this typical design. The mooring and anchoring system used in this plant has proven to sustain in recent heavy floods in Kerala. This is what when you have a unexpected the floods, what is going to be the condition of the HTP panels and all, that is to be discussed actually. But as far as our ferrocement plant is concerned, it was very stable. There was no issues at all. Even though the cost of ferrocement plant is higher than that of the HTP panel, ferrocement plant is made in site itself, which is certainly an advantage in difficult terrain. That's what it is. This typical design, the 11 kV substation is placed over the float, and the float is the flexibility to place a bigger capacity, as I had already discussed. Less space is required, that's been discussed. Then another is the floating solar environment, especially in the reservoir, will be comparatively cleaner than that of land-based power plant, and hence maintenance cycle can be reduced. That is an advantage of the plant. There is no land cost or land development cost, etc., in floating solar power plant, and the floating plant can be installed in short time comparatively. The power evacuation cost of the plant is that's been discussed already. That's a common thing. The shadow in the reservoir is comparatively low in our case, because the depth of the reservoir is not much. If the reservoir depth is much, then shadow will be more. That is there. But what we can see is we are getting generation from 7 to 5:30 like that, 6 o'clock. Up to that, we are getting generation. Floating plants, if used in the cooling reservoirs, will have advantage of less water evaporation. That's been discussed. PV modules. Then future improvements and suggestions based on the experience. Even though the floating solar plant efficiency increases with the reduced panel temperature, there is large difference noticed with ambient temperature and the module temperature, especially during the peak time of the day. An automatic cooling system using a water in the reservoir that operates based on the temperature information from the sensor can be used to bring down the module temperature, and the efficiency of the plant can be improved. I had already discussed the module temperature is more, means for 1 degree of temperature you will have a voltage difference of 0.4 to 0.5 percentage. That is the difference of voltage you get 0.4 to 5 0.4 to, I think it is 0.4 to 0.5% only. Then the equipotential earthing achieved by connecting the metal parts of the floating the remote shore is very, very vital for the safety of the operating personnel. Hence, by introducing an earthing monitoring system that can be connected to the SCADA, which monitors the condition of the earth, can be used for further improving the safety of the earth. Water level variation and flow velocity variations are important factors in mooring system design. Hence, while identifying sites, including dam, reservoirs, these factors have to be analyzed. Transformer used for the power should have K factor. That's normal thing when you do the solar plants. Anti-islanding, here there is an issue with we had a delta star transformer. So when one of the phase is one of the phase of delta side is open, still star side is on, and we had some problem with identifying the anti-islanding. That is another issue yet to be solved. Taken as the last not the one more point, it's the project cost. That is what we have seen that time. We have estimated the cost. It was coming around 10 rupees for one unit when we have calculated, but the cost was high. But one thing is, there was no competition at that time when the project was the project was done. There was no competition absolutely. So we had only two competitors, and the competitor with the HTP has quoted more than this that of the ferrocement. That is what happened, and finally it went to this. I do not know in detail about this, but competition was low. I think this may be someone has to do some research on this. As such, this is a project where it has gone through the heavy flood situation and issue at all. That is what is to be done. Cost wise, what will be the cost and all to be studied, and whether we can go ahead with this ferrocement plot. And another point to be discussed is, last but not least, the minimum water level requirement is a constraint, and every year during summer you will have an unutilized storage of water in the reservoir, because it is in the reservoir. You cannot, if you bring down the water too much, then you know that it is going to sit on the bed. So lifting it up will be very difficult or impossible. So we have to keep some water in the reservoir so that the float is not in danger of sitting in the bed. This is the disadvantage, because that much of water will be, storage will be lost, which you would otherwise be used for hydroelectric power generation. That is what the last point is. If you use high efficiency panels, the space requirement of the plant can be still reduced, and the considerably and cost can be saved. This is what is my presentation. I think I took a little more time. Sorry for that. I think I'd gone through my presentation, and now it is time for you. Thank you.
Thank you very much, Ayub sir. Yeah.
Thank you, sir. Thank you, sir.
Yeah. Now we'll open the floor for a couple of questions.
Mr. Ayub?
Yes.
Just one small question. To keep people stationed on the floating platform for operations?
I'm not got the question. Can you repeat once more?
On the floating platform,
Yeah.
Do you have personnel stationed there permanently or for the day?
Yeah, at present, we have the maintenance personnel there. An operator is there because it is in the contract period still for 5 years. So the contractor's engineer is there. One person is there actually. We have the SCADA system which will give you the details about the plant, but still they have placed one engineer there still.
So do you need to make any arrangement for that person there on the platform?
See, basic necessities are required actually. That's a good question. And that is to be done actually. In fact, we have not done it. But we have boat services there. They usually come and go like that.
Thank you.
Thank you, sir. Thank you.
Sir, thank you. This is Arindam from NPCL.
Yes,
first
sir.
of all, thank you. It's a very nice presentation. I know you are not from civil side, but one slide which I saw, there is a question in my mind. You said the floating plant requires less space compared to land-based plants.
Yes.
Can you please enlighten me on that? Because as far as I understand, according to the solar radiation and the angle of the thing, movement space all around, the space requirement for any plant should be standard at a certain space. So how it was less?
Normally it should be so. I think see, when you go for bigger plans, you should have more spaces for a vehicle to go, and maybe it is because of the land, the nature of the land, where you need to do some developments and then make. I do not know exactly what has been experienced. Is we are used only 1.23 acres of land for this plant. 1.23 acres of land, and maybe I do not know. Maybe see, you need another infrastructure, like you need roads to the big when the plants are bigger. Maybe that is the reason. See, you want to transport this plant to the maybe that is the reason. I do not know basically, but what we found is 1.23 acres of land is only being used. That is what we have calculated. And literature says otherwise. It is for the land-based plant, it is taking more space. That is why I mentioned.
I understand.
May I come in?
Yes, please.
So just to add to what Ayub sir is saying, one advantage of a floating solar plant is it's a regular shape. Whenever you construct a floating solar plant, it will be a rectangular shape. So there, the space design can be optimized. Number two, as Ayub sir said, the circulation area required in a floating solar plant is much less as compared to a land. So your vehicular movement, all your normal pedestrian movement, those are kind of constrained. So that is why we definitely see almost a 30% lower land area requirement for a floating solar vis-a-vis a ground mounted.
Actually, when we have used 260 watts panel with the same size. Now we have 500 watts panel. That means I can go with half of the size, or at least I can reduce to 25 to 30% still.
I fully understand and appreciate.
Because 500 watts panels are available now with the same size of this 300 or 290 panels, 300, 335 panels.
Hello, may I come in?
Yes, please.
If I see that video, for the total surface area, only a very small part is covered, and this 500 megawatt is planned. Is there any restriction? I mean, why you have gone only for 500 megawatt? Is it a test project, or because of that, or any other reason?
Exactly, it was a research and development project only, R&D, research and development project, and we are going for a 100 megawatt floating solar plant in Banasura Sagar. That is what is with SECI. We are going. Kerala State Electricity Board is going. We have the total plan of 350 megawatt as on now.
In the same reservoir.
No, there it is only 100 megawatt plant we are proposing, and the other is different part of state.
Okay, and now based on your experience, what is the, I mean, because of the nature's fury, what are all the, the maintenance aspects you have faced? Any difficulty you have faced in terms of panel maintenance, in terms of ferrocement concrete, and in terms of corrosion of reinforcement inside the ferrocement concrete?
Actually, see, that is what I told now. We have not faced much of the problems there. Even after this big flood, it withstood the flood. 2 times it has come, because it is a heavy structure. It is not easy to move also. It is just like.
One doubt I have, it is a hollow box of ferrocement.
Yeah.
In case the water gets flooded inside, it will completely drown down, isn't it so?
Yeah, exactly. Because now, because we have manholes and all, in case water comes, as Anil has told, we have some markings there, which is designed so that when water is reaching there, then it is dangerous. If more and more water comes, then it will eventually goes down. So we have a marking there. There we will see whether water ingress is there or not. So if there is during the monsoon season, we have some problems like water going in. So that we will pump out.
That is the water going through that manhole cover.
Yeah,
if it is due to leakage and cracks of the ferrocement.
No cracks have been noticed so far. No cracks have been noticed. Only what we could see is we have, in fact, we have done an investigation on this before we pass on the bill of the contractor. We have seen some water.
Period.
Yeah, we found out that it was coming from this manhole.
What is the total cost of the project, sir?
Sir, it is it is approximately, it has come that time 9 crores or something like that. It's very.
No, I understand. It is a pilot project. Any pilot project does have that. It is okay. I mean, just as a matter of interest, I asked. Thank you. Thank you so much.
Yeah, this is one of the things we don't want to disclose.
No. It is quite obvious. That anything which starts, it has to pay a price for it. Yes. Thank you so much. Thank you so much.
In fact, we did not have any competitors. That is what my feeling now. If there was any competitor, then it would have come down naturally.
One thing, since you told that now the panel capacity has almost increased double, is it not wise to replace the panel now itself so that we will have a more electricity production instead of waiting for the total durability period of the solar panels?
That can be thought about, sir. That we see. In fact, replacing the same place we have not thought about. In fact, we have to do some economical studies, and then I think it's a good suggestion, sir. We will look into it. We'll take up also. That's good one, sir.
Thank you, sir. Thank you.
So thank you very much, ladies and gentlemen. If we don't have any more questions, thank you, Ayub sir, for a wonderful presentation and a very professionally done virtual study tour. I mean, hats off to you and Anil sir and all the team in KCB for bringing out beautifully. Okay, last 2-3 minutes as a closing remark. If somebody wants to say on the overall program, I would maybe give 2-3 minutes. If somebody wants to comment on the overall structure, overall content of the program, 1 or 2 people if they want to say, or if you can also send us feedback later, fine. I mean, we used to have the feedback forms, but unfortunately, I think we did not create one for this virtual study tour, seminar or webinar or training program. In future, we'll do it. What I would now suggest is, I mean, the main organizers, the Central Board of Irrigation and Power, I would request Mr. Dasgupta, Mr. Madhu, and Ravinder to appear on the screen. I want to really, thank them for all the efforts that they have put in to make this really successful program. Mr. Dasgupta, Madhu, and Ravinder, can you appear on the screen?
Yes, sir. Yes.
You can't. Okay, all 3 of you are in one screen. Excellent. Thank you very much, Mr. Dasgupta. Ms. Madhu and Ravinder.
Thank you.
Yeah, yeah. Ravinder, once
After a long time, at least we are seeing in
yes.
this pandemic.
Yeah, Ravinder, we have about 40 plus people now. Can we have the photographs of people in batches of 9? It may take 5-6 minutes if that's possible. Then I would request all of you to please open up your videos, and then we'll have a quick picture of all of you. I mean, whosoever is available now. Yes, thank you. Yeah, maybe you can yeah, do that. Start. Yeah. Mohit, you are still not visible. Yeah.
Hello,
Mohit.
may I say something?
Yeah, please. Yes.
Yeah. First of all, let me thank all of you for taking this much of effort and making a beautiful 2 days presentation. And it was really an excellent and an eye-opener on this new floating solar. I have one small suggestion for the next program. Before start of this particular presentation, or as a first presentation, probably the details of the floating solar power system, including the the float, the connection, the mooring, the anchor, those things can be taught as a in initial what it means, and then the experts presentation like hands and other things can carry on, so that the participants will be able to appreciate much more those who are not having the beforehand knowledge of this.
Okay. No, well taken. Your comment is well taken. Sure, we'll do that. Yeah.
Thank you, sir. Thank you.
Thank you. Ravinder, you want us to, I mean, how do you take the picture? Yeah, you're taking the pictures, right? Yeah. In fact, hopefully by next year, we will be able to do the physical study tours again. I mean, with CBIP, as I had mentioned, we have had 5 successful study tours to different projects. Floating solar, PSP hydro, and then the battery storage. Then we also went to the large solar plants, wind plants. So hopefully we should be doing, and hybrid plant. Yeah.
Sir, if many more people can open their video, then they were
Please. Yeah, those who have not opened the video, please, can you, or you want us to close? I mean, those who have opened and clicked. Yeah, sure. So those who have been already clicked, we can close our video so that others can, we can turn off our cameras. Yeah, sure. It's for the record. I mean, we want to have the record of people and their pictures. Yeah. Can we have the next set of people? Please open your pictures, and then Mr. Ravinder will click. Yeah.
Yeah, and if they can just say something, then they will appear on the screen, sir.
Okay. Yeah, I think along with the video, you'll also have to open your audio. Yeah. For those who have not been clicked, so please.
Hello, everyone.
Hello.
Hello, everyone.
Yeah. Thanks a lot for a very nice session.
Thank you. Thank you very much.
Hello, everyone.
Hello, everyone.
Hello, everyone.
Hello.
Thank you. Nice session. Hello, everyone. A very good session.
Thank you very much. Thank you.
It was really informative session.
Thank you very much. Thank you, ma'am.
Hello, everyone.
Hello.
Hello, everyone.
Okay.
Hello,
Can I
everyone.
close now, Ravinder?
Yes, sir, you can.
Hello, everyone.
Hi.
Mm.
Hi.
Hello, everyone.
Hello.
Hello.
Hi.
Hello.
Nice to meet you.
Am I audible?
Am I audible?
Hello.
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 Yes, Ravinder, you're done.
I take around 5 to 10 pictures, so many more are
Okay,
covered,
all
sir.
right.
Yeah.
Okay, all right. Thank you very much. I mean, those were clear. A couple of more statements from my side. I think there is a small delegate fee which is being charged by CBIP to recover their costs. Please kindly, tell your organization to make that payment as soon as possible. Since you are the ambassadors of our programs, I would rather request you to spread a word about the work that we have done as part of this event. And all the presentations will be available on the website, and there will be a YouTube which will be giving the recordings of both the days. And as I said, once the COVID gets over, hopefully it should be quite soon. We will definitely CBIP and IGEF will organize a physical study tour. We already had planned one on the agro PV plant in Jodhpur, which has been put on hold now because of the COVID. I mean, we were planning in the first week of March of 2020, but somehow that had to be postponed. We'll start with that, and then we will also do a study tour to the wind hybrid plant and so on and so forth. I think with these, and e-certificates will be sent by CBIP in course of time. I mean, all of you will get your e-certificates. And CBIP is one of the reputed organizations. They also have the membership scheme. I think Mr. Dasgupta will send you the details. Whosoever can become member by paying the fees or whatever, please kindly see that it's as I said, it's the 95th year that they are into operations. See how you can support them in continuing their good work that they have been doing. And finally, from my side, from the Indo-German Energy Forum, in advance, a very happy New Year 2021. And I definitely look forward to seeing some of you in our future activities. With these few words, we come to the conclusion of a two-day program, and stay safe, stay healthy, and I really look forward to seeing all of you in future programs. Thank you very much. Have a nice day.
Thank you very much.
Thank you.
Thank you, sir.
Thank you. Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thank you.